Hi, my name is Dinesh Malav, and this is my final project presentation for Big Data Analytics class at Harvard Extension School. The topic for this project is image processing using OpenCV on Hadoop using Hippie. There are millions of photos taken and shared on social media every day. Processing large set of images is not possible with a single machine. The solution to this problem is to use distributed processing of images using Hadoop. This project demonstrates image processing using OpenCV tools on Hadoop. Hadoop Image Processing Interface, or HIPI, is an open source library developed by University of Virginia for Apache Hadoop. This provides efficient and high throughput image processing with MapReduce and solutions for storing large collection of images on HDFS. The HIPI system consists of different MapReduce tasks. The primary input object to a HIPI program is a HIPI image bundle or HIP file. This is a collection of images represented in a single file on HDFS. The first processing stage of HIPI program is a culling stage step that allows filtering of images in a HIB based on a variety of user-defined conditions. The images that survive the culling stage are assigned to individual map tasks in a way that attempts to maximize data locality. The records emitted by the map stage are routed to reduce tasks according to MapReduce shuffle algorithm that attempts to minimize network traffic. Finally, the user-defined reduced tasks are executed in parallel and their output is collected and written to HDFS. Hippie has three main classes: a Hippie image bundle, which represents collection of images stored together in one file. This file is used directly on Hadoop MapReduce framework. The float image class is a representation of an image. It represents image pixel data and supports common image operations like cropping, resizing, scaling. Cull Mapper class facilitates culling step before map for filtering images. Another tool that was used with this project is OpenCV, that is a open source computer vision library for machine learning. This provides more than 2500 optimized algorithms for various image processing tasks like face detection, face recognition, identifying objects, and many more. Here in this example, it shows how Hippie works on detecting front-facing faces. It does a pretty good job, except in few cases where it misses some of the object, which can be uh, eliminated by training the model and using different classifiers. This project combines OpenCV with Hippie for counting faces in set of images. Hippie provides efficient and high throughput image processing. OpenCV provides rich image processing algorithms. Used together, they can produce very powerful tools. In this case, counting the faces of images. There were various technologies used to do this task. Uh, the MapReduce program was run on top of Cloudera Quick Start VM running on VMware Fusion. Um, then Hadoop, Hippie with Hadoop and OpenCV was used to do the rest of the image processing. The dataset that this program was run were downloaded from CMView Face Frontal Image website and converted to PNG file formats. There are other sources for getting the face detection data sets, which can be used with Hippie. Hippie actually supports millions of files and that can be processed on the cluster. To configure Hadoop to run OpenCV, we need to copy the native library that it builds into a shared location, something like etc OpenCV lib, and set a Java library path to point to this location in Hadoop configure script so that this path gets exported and is available for Hadoop to use it. The mapper function in FaceCount MapReduce program loads the OpenCV native library, then creates a cascade classifier, converts the hippie float image to OpenCV matrix, and then detects faces and counts the faces in the image. And then finally it routes the output number of faces detected to the context, which is used by reducer to count the number of files processed and faces detected. Then finally the output number, and then the output is returned to HDFS. OpenCV requires the classifier XML files to be available to detect objects or faces. This can be achieved by using the add cache file function of the job, which sets a URI to point to a location on HDFS. This location then can be accessed in the setup function, and a face detector classifier can be created to be used in Mapper. Another area we need to focus on is to convert float image to OpenCV matrix. This is achieved by just walking through each pixel and converting it to RGB value that matrix supports. There are two major steps to running hippie MapReduce program. One is to create a HIP file and then run actual MapReduce program. Let's do a demo for detecting faces using OpenCV and running the MapReduce task on Cloudera VM. So I'll switch to this. I already have some images created here. I'll basically delete those images first so that we can start fresh. Before we do, let's go through the code to understand what exactly is going on. To detect the faces, a classifier XML file must be loaded into the system, and a cascade classifier is created. Then the image is loaded into matrix, and this matrix is used along with the face detector to detect the faces in the image, which are counted, and a rectangle is drawn around it, and the image is saved in the local directory. So to run, I have already built my Java program as a jar file. To run this, we will run this jar file along with the class path provided to the OpenCV jar and Java library path provided to the native library for OpenCV. And it also accepts a path to the folder where the images are stored, which we need to run, which we want to run face detection on. So if I run it, it goes ahead, runs it, and creates these different images, and all the faces are correctly detected, which are front facing. That's one example. And then next we can run a MapReduce program. Before we do that, let's switch to the code and see what it exactly does. This is very similar to the code that we ran for counting word count, except this expects a input HIP file and output directory where to output the results. So so this is very similar to the way how we set up the MapReduce jobs. The only difference is to adding this new cache file from the HDFS path so that it can be accessed into our mapper function when we are creating the cascade classifier. In the mapper function, we run a setup or override the setup method from mapper to basically load the native library and get the cache file and create a new cascade classifier. Once it is created, uh, the once it is created, map function, it verifies the images, and then a convert float image to OpenCV matrix is done. Once the conversion done, a count faces function is called to count number of faces, and the output is written to the context to be used by reducer. Reducer just goes through and counts the number of images available and writes the total output at the end to on HDFS. Let's go back to the Cloudera VM and run and see how we can run this face count program. I have already compiled a face count jar, and first I create a HIP file using a tool provided by Hippie to create HIP import jar, which takes a path to the images where the images are stored and creates input HIP file on HDFS. This input HIP file is then used to run the MapReduce function, and the output is written to project output folder. I have already run this job. I ran it on a small sample and it says that we have 17 images, but it didn't detect any faces. After debugging, I found out that the function for converting from hippie hippie image float image to OpenCV was not working correctly. I had contacted Hippie but haven't heard anything before I published this view. So let's go back to the presentation. So in the summary, the wrapper function to convert my hippie float image did not work for some reason, and due to that no faces were detected. There are many benefits to combining these technologies to produce powerful tools for parallel image processing. But the image conversion wasn't straightforward as I expected, and it failed to detect faces. But there were some important lessons learned from this exercise. Were to setting up a Cloudera Quick Start VM, like using Hippie to run MapReduce on large volume of images, using OpenCV in Java environment, setting up Hadoop to load native libraries, and using cache files on HDFS. Thank you.